Welcome once again. It's new teacher Edward taking you through applied mathematics, and we are still under the same mechanics, but topic which is still the same, components and resultant of forces. So we have been at resultant of forces. But first and foremost, we have already seen what a force is. You can now define a force. You can calculate forces or resultant forces for particles which are acting on it concurrently. And then we are looking at calculating a force which is acting at a given angle, which is not horizontal, which is not vertical, but it is acting at an angle. How do we calculate the resultant of that force? So that's the equation or the derivation we are going to do. Now, we said in the previous example, we considered the force F, but let us now make it force P. If you have force P, if force P is acting at an angle star. If we have force P is acting at an angle star, how do you calculate that force? The force P is acting at an angle star as shown. How do you calculate that force? So this is our force P. This is the point where it is acting. It's acting at an angle star. This is our force P at this angle star. So from previous example, we said that this force is having both vertical and horizontal components. And then we looked at how we can calculate the vertical component of force, and then how we can calculate the horizontal component of force. So let us say that the horizontal component of this force P will be Px, because the horizontal component is in the x-axis direction, or is in the x-axis. Our x-axis represents the horizontal component, which shall call it as Px, and then our vertical component of this force, you can put it there or you can have it here. All of them are the same, but for not confusing you, let us put it this side, that this force will act on in this direction, which is Py, because it's what acting along y-axis. So we said if you want to get the vertical component or the vertical component Py of this force, we get the vertical components Py is given by the vertical component Py is given by Py equals to we said it is that force times its angle. That is, it is the force times the sine of its angle. The force is P, and then the sine of its angle is called sine star. It's given by P sine star. That's what we looked at. And then the force, the horizontal component, components of P, which is Px, is given by is given by our Px is given by Px equals to, is given by Px equals to the horizontal component. We said we use sine star. Px equals to sine. The horizontal component, we said we use cos star. Sorry for that. Our horizontal component is that force P sine, which is cos, P cos theta. So these are two components of forces which we are looking at. This is from previous lesson what we have been looking at. And then what we are going to do, in case, here we have been looking at one force, but in case you are having more than one forces, more than one force acting in different directions, but not to that horizontal, how do you resolve those forces? Since we know how to get the forces, the components, which is horizontal components and the vertical component, then how do we even get the resultant force out of these components? Because our topic is saying components and resultant of forces. We have so far looked at how to get the components, that's the y and x components, which is horizontal and vertical components as shown in this diagram. But let us proceed and see how we are going to get the resultant force out of these forces. We consider what we are doing next is we consider forces P and Q acting on the body as shown. Acting on the body as shown. So this is our body, or this is our body, then this is our force P. This is our force P. Force P, and then this one is acting on this direction. Then this is our force. This is our force P, and this is our force Q. P is acting at an angle star, and Q is acting at an angle alpha. So we are going to look at determination of resultant force of two or more forces acting on the same point or at the same point, or which are acting concurrently but at different angles. So how do we get the components of forces? We have two components. We said we have vertical components and horizontal component of force. And we said when you are getting vertical component of force, you use that force and then you multiply by the sine of that angle. Then for horizontal component, we have the force and then times the sine of the angle. So let us start with this one. You take particle one at a time. For start, let us take particle one at a time. We consider particle P. So we are going to consider particle. We're going to consider force P acting on the particle. Consider force P. This is our force P. It's having both vertical and horizontal component. This is horizontal component, this is our vertical component. Consider particle P. So our particle P is having Px this one is our Px and this one is our Py and Px respectively, Py and Px. So this one is, so for particle P we have Py and Px. Py is the vertical component and then Px is the horizontal components. But we say the components of a force which is acting at a given angle is 2. One of them we have vertical component. So vertical component of P is given by, since we are considering force P, we are going to consider force P, not particle P. Since we are considering force P, this force P. Since we are considering force P, so we need to get the vertical component of force P. Then how do we get the vertical component? Vertical components vertical components of force P. We say that vertical component is given by, vertical component of force P is given by, which is our Py, is given by P sine star. Why is it sine star? Because this force P is acting at an angle star to the horizontal. This angle alpha is not for P, is for Q. The angle alpha is not for force P but is for force Q. So the vertical components of force P is given by P itself times the angle which is P sine star. So then after getting the vertical components of force P, we shall come to horizontal components of force P. Horizontal components of force P. What is our horizontal component of force P? Horizontal components of force P is in that direction because our force is in this direction. If it was in this direction, going this side, then the horizontal component would also act this side. Then if it was going this side, we shall see how it would act from force P, I mean force Q. So our horizontal component of force P is given by Px equals to, we said we get the force which is P times the sine, the cos of the angle. When we are on horizontal axis we use cos. When we are on vertical axis we use sine. Vertical sine, horizontal cos. So those are two things which you should master in this lesson, that when you are generating the vertical component of a force, use that force times the sine of the angle. Then when you are getting for horizontal components, you use that force then times the cos of that angle. So that's the particle P. Then we have two particles. Consider particle Q. We are going to consider but force Q. We are going to consider force Q. Consider force Q. So on force Q, we also have both vertical and horizontal. Now this is our force Q. Force Q is acting to the direction going downward, and it is going to the right hand side. So where will be our horizontal components? Horizontal component of force Q will be the same direction with horizontal component of force P. So this one will be also QX. So the vertical component, since this one is going downward, the vertical component of force Q will still go downward. This one will be our QY. Because, why is it going downward? It is because this force is acting to the direction going downward. So when you get the vertical component of it will be downward. But for horizontal, since it's in that angle which is going downward, but it still is going in the right hand side, so that's why the horizontal component also go in the right hand side. So if it was going this side, then the horizontal component would have come on the left hand side. So that's a difference. But now in calculating the components, we are using the same formula, that it will be this angle times its angle times the force, and then its angle times the force for vertical, which is the sine, and then it's the sine of its angle times the force of for vertical, the cos of its angle times the force, you get the horizontal component. Let us start with the horizontal component. Horizontal component or vertical component . Vertical components of Q is given by our QY equals to, our QY equals to, we said we get, no matter the direction where the force is going, but the method of calculating or the procedure remain the same. We are still using the same procedure. So we use the force, which the force is Q, then Q times the sine of the angle. Those are the two forces which we are looking at. It is given by Q times the sine of the angle. But for this case, the angle, you see, not star, is angle, the angle which we are considering is angle alpha. So it will be Q times the angle alpha. Then you get the horizontal component, horizontal of Q is given by QX. Is given by Q. Then he said we get it by cos of the angle. We get Q and cos of the angle. Those are the two components of forces. Let us illustrate them on our particle. So in the next video, we shall look at how we are going to combine these forces to form one force and how we are going to generate it. Thank you.